Okay, so this is the topic, challenges. So this is basically a topic that I will kind of introduce in this fashion. Initially, the structure of an EV and a HEV. So even though this workshop is oriented towards EV, I will say that HEV or the hybrid electric vehicle is definitely coupled, especially as the national scenario is concerned. So I think I will touch upon that because HEV is more appropriate for India than EVs. But anyway, we will discuss that. As far as Powertronic goes, doesn't change. Then some challenges in the wheeled e-mobility and some challenges in the non-wheeled e-mobility, and that is something that I feel the people should go towards, but anyway, it is not going towards that, but research can go towards that. So I will put up some challenges towards the non-wheeled e-mobility. And finally, a 1-minute video on the implementational issues that has come in the past 2 decades. Okay. So if you take EV as a topic is very, very broad. It touches, it's a highly interdisciplinary, it touches various topics. Of course, we are generally in this propulsion, powertronics guys and recharge solutions. These are where mostly we focus, but EV is much beyond that. You have security solutions, control algorithms, body mechanics, which is a very important part of reducing the air frictions, communications, intra-vehicle, inter-vehicle communications, all these things, right? So if I click, you will see that there are several challenges that come up, and these are all the challenges which everybody is working on. World over, people are working on these various aspects. And I feel that our workshop here is focused more in this right-hand top side portion of the this one, which is basically propulsion, the various topologies, inverters, drive control, special machines, and recharge solutions, V2G, G2V, these kind of things. We will discuss what it is. So mostly I will try to give a feel on this and on this right-off S-plane. Okay, this right-off side, and hopefully it doesn't go uncontrolled, and we will get back on track. Okay. So first, the propulsion system. What does it comprise of? What is it? Okay. So the block schematic. Okay. Let me say. I will also show you some implementational this one that we have done right from 2000 onwards, and you will get a feel for that. So first is the energy source, and that is where the whole problem is. That is the weakest link. Energy source for our eyes is the petrol, diesel. That is the best that nature can provide. And no amount of battery and no amount of battery innovation is coming anywhere near it. That is the thing. If you talk in terms of energy densities, 1 kg of petrol would contain somewhere about 12,300 or 12,500 watt hours per kg. And the best battery today will give only 250 watt hours. So you see a difference of 100, kind of factor of 100. So we cannot beat nature in that, and therefore you have to lug along a lot of weight to get the same range. Okay, so that is the reason I say HEV is always better, and there are few other reasons why HEV is better, but there are several political regulations which want to go for EV for different reasons, not for academic reasons or this one, but we will only talk academic. Okay. So energy source could be fuel cell, it could be any of the batteries, it could even be a lead acid battery. The first, before we used to use lead acid battery, I don't see anything bad in that also. You have a DC-DC converter which will come in between to e-battery. Why I say e-battery is that it is a bank of, it's a battery of ultra caps, and this is the one which actually will give you the acceleration capacity, the power density is the one which you look for when you are designing that. So very high power densities can be obtained by this ultra cap. So it's a bank of ultra caps, and that is necessary, that actually makes the DC link. And then further on, of course, powertronic guys, you know, there is inverter, and then you can have multi-level inverters, two-level inverters, so on and so forth. The motor, again, the motor is something that we don't know which will win the race. Okay, there are several motors, several contenders. You have the induction machine, the stable workhorse, which all locomotives are using. Everywhere it is induction machine. But why people are not using induction machine in the cars, I don't know, but I think it is something that has to do with the character of the machine itself. It is when you are operating it with it, you will see that the parameters of the machine keep drifting. Okay, it will keep changing. So, and therefore your control dynamics will get affected, and therefore induction machine is not so preferred. It is very much complicated to control an induction machine than a DC machine, than a permanent magnet synchronous machine, or one of those synchronous reluctance machine, and even a switch reluctance machine. So there is competition: induction machine, switch reluctance machine, synchronous reluctance machine, synchronous machine without magnets. Okay. So the permanent magnet brushless DC and permanent magnet machines were quite popular, but now people are a bit wary because there are no permanent magnets outside the control of one country, and therefore 99.5% of the world's rare earth resources are controlled by one particular country, and therefore people are very wary of going towards a permanent magnet machine. So if you are doing any research on special machine, do it without permanent magnets. That is the better way to sell the product. Okay. So then to the wheels. Okay. So you have alternate sources. So you need one single source is not going to hold water. So you need to have multiple sources, and even a eutectic combination of sources. So it could be a lithium ion, lithium polymer, or it could be another set of batteries, or it could be another set of fuel stacks, or supercapacitor bank, or even flywheel. Okay. All that can charge up this high power density e-battery. These are all low power densities, high energy densities. So when you are choosing the batteries, high energy density batteries you choose for giving you the range. Okay, you want to go from here to Mysore. So you will look for a battery with high energy densities. So the challenge is, so I have my vehicle and I would like to go from here to locally travel, and tomorrow or probably the week after I would like to go to Mysore, or probably later on to Chennai. So I should be able to switch to eutectic combination of batteries, swap eutectic combination of batteries which have differing energy densities. Okay. So that is a challenge which right now no EVs are doing, but it is something that is where it is desirable. That's where you would like to go. So why the multi-power port? You will see that it is one common point of interface where you will charge from a PV. You will have the different sets of batteries pumping into the battery, and then you will have, when you brake, you will have the power flow in reverse and then charge up the battery, right? And you can also charge from the grid. Okay, so this is the grid interface is slightly more complicated in the sense that if you are having one EV or a few EVs in the city, no problem. But if you are talking of all the vehicles in the city are EVs. Okay, so evening you come and everybody puts them to the charge. So the grid will go down. Okay, that's it. And once the grid goes down, it doesn't see the load, and then it will come up. And then you'll see that the grid again sees a heavy load, and then it will go down. So it will start having a problem. So you need to have a very intelligent solution. So V2G solutions are something that really is scope for research, where the batteries in the EV will act as buffers, and like you take out energy from the battery and then put it back in the same cycle reactively. So it is, they will, like your synchronous capacitors, so they will act as these kind of buffers, which will stabilize your grid. And which means which battery should I use as a buffer, which battery should I use as a source, which battery should I use as a sink. Now that is where the issue will come among the million EVs which are plugged onto the grid. So that is the challenge which will start coming in. Okay. So before we go forward, something on the energy budget. So this is these are some numbers obtained from having electric vehicle moving in the campus. So several rounds of campus trips within the campus, not gone outside this one. But you should take this as a feel, in the sense that the road qualities are much better within the campus than outside, and so the rolling resistance is on-campus rolling resistance, and there is not much wind, opposing wind, so therefore the air drag is also minimal. So under those conditions, same weight between an IC engine and electric vehicle engine, this will give you some feel for the numbers of how much energy that is going to be consumed. So if you take this fellow, okay. So if you travel 1 kilometer, you will need 80 watt hours for the wheels, 40 watt hours. This is not under acceleration condition, under stable, steady velocity conditions. So battery charging losses, transmission losses, there will be a gearbox, a fixed gearbox, and then it will have some loss. And 4 units, 4 watt hours will be put back due to braking up, and you will have this up and down roads. So input 144 watt hours. Out of the 144, you will get back 4. Okay. So that is what you will see at the wheels, means at the vehicle. Okay. And this guy is slightly more, in the sense that 80 watt hours, 20 watt hours is okay, more or less. That will be fixed. The 500 watt hours in the engine loss. Now that is where the people are thinking that they are going to save the climate and save the earth, but it is not so. Be wary of this. You will see a lot of advertisements. Green power, EV is very green, and all those things. But what we have only done is that we have shifted the pollution sources from the wheels to a central source, maybe manufacturing of the batteries and things like that. You are not going to save much, and especially in a coal-driven economy like ours, it is transmission losses, it is going to be much worse. So better to use the ICE if it is from the saving the planet wise, but if you enjoy driving EV, just enjoy it. Don't say that it is green, but even though the board is green. Okay. Here is some, again, there are some myths here. Okay. So on the left-hand side is the EV. Okay. On the right-hand side is the ICE engine. Okay. So ICE engine, one significant advantage is that it is using the best fuel on the planet. Okay. The best power density, the best energy density fuel on the planet, which is around 12K plus. Okay, 12,000 watt hours per kg. No other source on the earth can match that, and the lithium ion is at 1250. This is lead acid battery, 35, very nice, right? Watt hours per kg. So you will never be able to, at least in the near future. Okay, I can safely say that because I don't know chemistry, but chemistry guys, you will have to work real hard to to get to the energy densities which nature provides. So petrol is that, diesel is also around that much, coal is around 10,000 to 12,000. All the fossil fuels are 10,000 to 12,000 bunches there. Okay. So I would, and on the other hand, if you look at the efficiency, efficiency of the ICE engines, 15% I have put on an average, but today's ICE engines are at 22%. So you can you have the good machines which are even 25%, and you have the bad machines which are still lower. But on an average, I can say that 15% on the ICE side and 70% on the other side. It is not the electronics. Electronics, the inverters are much more efficient, but you have again the battery chemistry coming in, the charge discharge of the battery. You will see that the conversion loss there. So 70% I will say. But this doesn't take into account the energy chain coming from, so you lift up the coal, and then coal is used for burning the, you burn the coal, and you have the heat engine, the turbine and the steam turbine, and then transmit 28% loss. All that if you put, it will be very horribly down. Okay. So, so anyway, we will talk just only from the EV point of view, not this side, otherwise we will get very discouraged. So EV point, enjoy power electronics, enjoy the EV, that's all. Okay. So let us just see the composition, components, what goes in. So this is a typical ICE engine. So I am representing the internal combustion engine as that, and then you have the differential and then the wheels. Okay, this is what we have been driving all along. And we have an alternator. Normally in all this, we have an alternator charges the battery. So I will say that you make it big, you redesign that alternator, and then to that shaft I can have that alternator, and then a DC-DC converter. The DC-DC converter we know how to do. Power electronics is a solved problem. So today we don't work on power electronics. Kaushik, excuse me. We only work on the software within the embedded software controlling the power electronics, but power electronics is actually within an IC or within a module. So it is a VLSI, power VLSI problem, no longer a discrete electronics problem. But anyway, we will still say that power electronics definitely plays a role, but not much research content there. You know how to make it, or you can buy it. So that charges up the battery, and we have a multi-power port. Okay? A multi-power port is again needed because you are going to interface several ports. And then you have the DC to AC. I put DC to AC because I am favoring the induction machine, but it could be any other machine. Okay? And which is going. So these are all the components that come in. Okay? So if you take the EV mode, it is just this much that will be used. The power flow from the battery, and the some battery is charged externally through the multi-power port. Okay. If you take the parallel hybrid, I am also activating ICE engine and also having the battery. Both the guys are pushing the vehicle, and therefore parallel hybrid. So this is how it would look like, at least. Okay. And the series hybrid. Series hybrid, this part, I have removed this part. This part is grayed out. Okay, there is no connection. So this ICE engine is operated at highway drive. So assume that the ICE engine is operated at its most efficient part, decoupled from the road, and sorry, you will be drawing the grams per kilometer drive at its most efficient way. Okay. So you will set it for that, and then you have the rest of them, and it is like in series in the sense that you have one source pumping to the battery, and the battery pumping again to the road. Okay. So that is the series hybrid. More interesting is this combination hybrid, where you have all possibilities. Okay, so you have the ICE engine driving and also the battery motor combination driving, pushing both together, parallel mode. Could also be operating in series mode. I am standing on a traffic signal, and therefore this can be charging up this, and then power flow. So series mode. So all this can happen simultaneously. Okay, so this is power electronic wise a combination hybrid, but Prius had a much wonderful design. It uses this sun planetary gear system. This part actually, you see that there is one shaft here, there is one shaft, there is another mechanical shaft, and there is another third. So you have 3 mechanical shafts coupled together. So it's very difficult to get omega addition, means speed addition, okay, in a mechanical this one. So sun planetary gear system is very, very interesting. So this is that. So here, this is the alternator. This is the alternator here. Okay, this will go on to charge the battery. Like this will go on to charge the battery, right? This fellow. And this fellow is the main motor. That is this motor, which is connected to the wheels. Okay, it is connected to the wheels here, right? And the IC engine is connected here, and through this chain drive, it is connected here. Now, this is the crux, this fellow here, this central part. Now, that is sun planetary. So, you have one gear, and then you have 3 planets moving on that, and then there is a ring which moves on that, right? So, these 3 are 3 different axes operating at different speeds. So, that is how this is interconnected, and this is kind of run for 2 decades. So, 2002 Prius came into the market, and still it is very popular, and this is something that I would say very revolutionary in the context of the EV. I think even the High Rider uses this now, but a much more evolved one. This is the very old one, but the evolved version of this. Okay. So, just some old shots of a series hybrid. Okay, we took the chassis and then built around that, and then make this one. This is very old, 2003. Okay, so this is where we start. This is where we first started learning. Very horrible inverter we made at that time, but it ran. But still, but now I would not do the inverter in that fashion. But all those things. So then later on, much later, we did this parallel hybrid. Parallel is very good for retrofitting. So you have the other wheel which is not driven, and to that you put the electric drive, and you can seamlessly retrofit. Now, this is a problem that will come. One of the challenges, what are you going to do with the millions of vehicles which are there already on the road? You can't put another million, right? You have millions, many millions. You will have to remove this. Where do you keep it? Where is the real estate to keep that? So, what is the archival method for that? That is a serious challenge. So, we can't just change it to electric. So, one way is seamlessly shift. So, the bridge would be to retrofit. So, I would say this is the way you can probably do that. Retrofit, go into the parallel hybrid mode, still use petrol and this one, gradually decrease the petrol part and go towards EV if you want to go towards a pure EV mode. But I would not recommend to go to the pure EV mode by different reasons, because you are actually not going to save the pollution levels or this one. You will reach an equilibrium somewhere in between 40-60 kind of a thing. That would be the best situation. So, you need to have this kind of this. You cannot overnight change whatever happens. So, you need to move seamlessly, gradually into that one. So, this is the parallel hybrid mode is something that you can actually do that. Okay. So, these are all done by the students. I think Prasanna is here, Sudarshan is here. I see them, so they are all familiar with that. They have kind of took the initiative and did several of them. Anyway, so this is the present model which is there running in the department. This is actually an open source chassis. So you can buy this open source. Why it is called is that they give all the drawings of this one, so we can modify and then do and custom make it in. So in our workshop we have done a lot of customization, but you get an open source chassis with all the documentation for that one, which is, so this is called Tabby. So you can go to the net and then probably buy it if this one. But so you don't need to break your head on several of these suspensions and joints and universal joints. Several of these things are done. So to this, so we have attached this radiator here from an Alto. So we got an Alto radiator, bought it from the local Yeshwanthpur market, and then fixed that one here. And this here is the inverter here, and then we have the backside on the lithium polymer batteries. This is another thing which I will not be discussing here, because this comes on the left of this plane, in the sense that This is a smart windscreen where other IoT and communication people are working on it to work on what do you call anti-glare issues and issues the smartness in the sense that you see the map on the screen, and you also during the night you can make it translucent, during the day it can be transparent, all those things. So those kind of things are being done. So, but I will not touch upon that. So that is there. We are more interested in this. So there is a motor here. Okay? So there is a motor here. Probably I have a clearer picture of that one. So this motor, it was there here, it is remote. So the motor, it came when we bought the chassis, along with it came a motor. It was a very horrible motor. So when you test the motor, you see that it is not sinusoidal in distribution. It is having stepped flux distribution, very horrible. So initially we did do some running with that, but it was the waveforms were not something that you will be proud of as a power electronic engineer. So that is removed, and now that is rewound. So that is rewound for a sinusoidal distribution. So that will be fitted in, and hopefully the newer students will move it along the campus. Okay. So this is the drive made by the student. So what the PCB is the one which is done by the student. The base enclosure was broken down semicron module. So it was completely potted. So we had to dig it out. So dig out everything, make it into aluminum this one, and then on that relayed the capacitor bank. So that is this is the capacitor bank here. Okay, and this is the. So the interesting part here is not the power electronics or the DSP board here, which is a 4-layer DSP board. Interesting part here is the thermals. So you have water cooled water entering here, through this pipe, and water leaving out here, and underneath here is the IGBT, and you have the cold plate through which the water kind of circulates and then removes it by mass transport. So the challenge there is design of the heat removal through mass transport, and that is where the a lot of importance goes in there. So this is testing it in the lab. This is the inverter combination with the DSP, and then this is the radiator, all put together to test that. This is a standard vector control waveform. Okay, so then we wanted to remove the semicron enclosure and then put our own enclosure. We redesigned it. This one? Okay, no problem. Okay. So here, now let's say this is the enclosure. So there is an inlet and an outlet, and this under this is where the fins will be there. So this is how it will look like. The fins which are milled out, these are milled out, and water will flow through like that. Water will flow through here and then goes in and then comes out. So it goes in a zigzag fashion. Okay, it'll go through like that and then comes out. Okay, so these are milled, and it was actually a complicated process. Now thinking back, there are much better ways to do it. So we first did a sand casting. So you have a sand mold foundry, and then pour in the aluminum and then machine it, and then afterwards plug in these bushes here, okay, and then do that. But that was very, very complicated. Probably for one-off process it is fine. But the main point is that designing these plates, underneath it is the fins pointing down, because the water goes in and comes out through that one. Okay, so the electronics, probably what will be of interest to you, power electronics, is that internally it is nothing but this is as I said, the capacitance, and this is just 2-level inverter, 3-phase, okay, and this is the thermal section, the water coming in and out, and this portion is the control board, DSP 320 F28X series, and the induction machine. So this is basically what goes into that drive. Okay. So how do we test? It is a 300 amp device, and drawing 300 amps from the source and then trying to test is very, very difficult. So you need to have this kind of a setup. So you have the grid, okay, and then you have a front-end control. So front-end control is like a transformer-less grid-connected inverter. You think of it like that, okay? It's a transformer-less grid-connected inverter, what they use for PV. Let's say you use that, okay? And assume that you have control on the control board. Okay? So this you operate it in voltage control mode and set the ID or the STATCOM direct access to draw power from the grid. So draw current from the grid, voltage is fixed, right? So this is in voltage control mode, and this is the inverter under test, whatever inverter that you are building, okay? This is the inverter under test, and you have the isolation. So this is a 100 kVA transformer in the lab, and this feeds another inverter, standard inverter, and another front-end converter. This is like a normal transformer-less grid-connected inverter pumping to the grid. Assume that PV is pumping to the grid, that kind of a thing, setup. Okay? So this is FEC1, front-end converter 1, front-end converter 2, and this inverter. So these blue portions are sitting here, okay? And on the back of that are the inductors. Inductors are really huge guys. Okay? So you set let us say 100 amps here. You set 100 amps. So this will act as load for this. This will act as load for this, so on, and load for this. So we'll draw that power from here. So it is a difference amount of power that you are going to draw actually from the grid because of the looping back. So this is the setup which is there. This is setup for 100 kVA, but the inverter is designed for 250 kVA. And testing the motor, slightly more difficult. So we have a lower wattage test setup. Similar, what you do here is not a fixed ISD that you will give. You will give based on the city drive cycle. So city drive cycle, how you do? You run around the city. Means you run not by walk. You take a vehicle and start plotting, and then you could also take standard drive cycles which are available from the standards, but nice to actually run around the city and actually get the kmph versus time. Okay, so you will actually, so you do it many times and take an average kind of a thing, and this will give you the city drive cycle. And as the voltage is fixed, it is you can find V into you can find the power here and actually set what should be the current there, okay, by scaling. So this will act as the load for this, which will act as the load for this, and the load for the induction motor under test. So induction motor is seeing as though it is driving on the roads. Okay, so that will give you kind of the behavior of the induction machine. So this again loop back and what you draw from the mains. So this setup you need to have, otherwise you will not be low power. You can test, but once you start going to higher powers, becomes difficult. Okay, another major power electronics kind of a thing is the recharge. Okay, so in the recharge, there is lot of research going on fast recharge, but again, from our country point of view, is what I am just trying to say, that this is again a coal-based economy, and where is the power? We have our economy is again deficit power. Okay, power economy is deficit, so we have more loads than we can supply, and this is what has to actually supply your recharge. So you are talking of fast recharge means you are talking of a very, very high power demand. So the questions that you need to ask, is it really better to go in for an EV or an ICE? But if you are having renewables, all the parking lots you have renewables, okay, and you make it a point that you charge only from renewables, then yes, makes sense. Okay, then it makes sense that you are taking only the renewable power in, and then the transmission line losses won't be there, all those things. But means on the minus side, you need a lot of real estate for that. So imagine the amount of real estate that you would have. So whatever the fast charge, the fastest I would say is 20 to 30 minutes, and that is still quite a long time. So you go into a petrol bunk and then you stand there, fill up the petrol, and then get out. It is 3 minutes on an average, if there is no queue. Okay, but even for that there is a queue, right? Now if you talk of you go in 20 minutes and out, or 30 minutes and out, the queue length will be really unmanageable, and if you are talking of all having turned out. Fast charging, not feasible, but you can do research on that. But the point is that what is actually, see, that's where the battery is the weakest link. The fossil fuel is so beautiful. It's, I should not be telling this. People will come and hit me. But the point is that nature has made such a beautiful fuel, but we are wasting it in a undefined fashion. But the point is, it is so actually compact, and over the years it has made, but we are not able to get anywhere close to it. And in trying to make it more compact, we are creating more pollution to make that compact batteries. So it is something very strange. If all of them are going to demand in that 30 minutes very high power, what will happen to the other loads? So keep a thought on that. So these are things that you need to, these are challenges that you need to actually overcome. Okay. So as I said, we can customize the chassis. We have put in something here, okay, in our workshop. So that is connected to the steering rod, and we are fixing a steering motor there at this point for purpose of steering control. Okay. Why is that needed? So there are several advantages. There are several research angles in this part. Though doesn't directly come in power electronics, but it is control of power electronics. So therefore, I thought it is relevant to bring it here. Okay. So autonomous steering, assisted steering, platooning, remote platooning, smart mapping, these are all the applications that can fall into this. So when you say autonomous driving, it means that no pilot, no driver, so driving without the driver. And when you say remote driving, so remote driving means that there is a driver, but he is not sitting in the car, he is elsewhere, but still driving, that's a remote driving. Okay. And driver assist, what driver assist means is that a driver is driving, but he falls asleep, which is common. In fact, majority of the highway accidents are due to driver fatigue. So when you are driving long distance, at least when I am driving long distance, I tend to doze off. My Mrs. keeps doing that, but apparently I hear that it is same for many people. So the long distance driving, this happens, and this is the cause of several of the highway accidents. And when the driver starts going into sleep mode, means, or at least the doze mode, the assist takes in and does autonomous driving. And when the driver starts shaking his hands, or what means there is a thing of you are able to detect that he has woken up or he is active, seamlessly it is handed over to the driver. So driver doesn't feel that he has dozed off, but actually it is handed over into an autonomous driving mode. So this is becoming very heavy research oriented, and lot of work is going on in that one. Okay. A simplified kind of a block diagram is that you have this traction control, means all this vector V by F control, vector control. Most of the drives will be vector control, let us say. So let's say all that thing is there here. You are able to set the torque. So they are all torque control mode, right? Not speed control, because your foot pedal when you are in the car is controlling the torque. The speed is controlled through your through your brain. Okay, you are the speed controller. So as far as the vehicle is concerned, you give a torque reference. Okay. there is another motor to control, which is the steering motor. So the steering motor, where you need to give the angle, and the second motor. Okay, and the only sensor that you can give a license for is the vision sensor. Okay, there can be LiDAR, there can be several ultrasound, ultrasonics, all those things, but license should be given only to the vision part of it. So which means it should be self-contained with vision, in the sense that you cannot go and hit a person or hit anything only based on this one. So with vision sensor, you know how to drive. That is what it means, and you are not going to collide with anybody. However, I may not know how to go from A to B. That's a different problem. Okay, that Google Maps and all those things will start coming into the picture. But a license is given for anti-collision. So just with vision sensor, you should see that in all possible forms, it doesn't collide. So that is the challenge, and that is where the importance comes in. So each person can have their own driving character based on the vision. So vision could be that you go, you enter in, you fit in your mobile, the camera of your mobile will be the vision, and then your character of driving will be in the algorithm, and the vehicle will be driven according to that particular character, which is based on. So just a monocular lens is your ultimate sensor, and then this is going to give the torque reference, or generation of the torque reference and the angle reference is the crux. Very, very difficult. This is a research problem, not done still now. And yes, there are several autonomous driving prototypes which are there across the world, but not with only a single monocular vision sensor, and that is the important thing. More number of sensors means that you have a reliability issue, one sensor failing, and you will have an issue with collision. So you need to give a license only to that, just like humans. You give a license only to the guy who can drive with these visions. Okay. So that is important. Platooning, this is coming up big way. Platooning means you have a fleet, you have a platoon, you have a fleet of vehicles, okay? Fleet of lorries, you have a fleet of buses, a fleet of cars, and one driver. So sitting in the front is driving, and all the others are following the leader, kind of thing. So in an autonomous way. So this is control, which third one, dream world, but it is something that will come up in the future. Traffic currents, just like, so the name is coming from ocean currents. So in oceans, there are several currents where when you get into the current, it will take you along. It will take you along and then leave you somewhere, okay, wherever the current ends. So the applications where people are seeing this is that many of the traffic junctions, you are standing maybe 2-3 times. The traffic cycle goes, right? Red to green, so on. You are just making a move, and then, but the reason why it happens is that cascading. So the person in the end doesn't know what is happening in the front. So it is a very big buffer, and they all switch off the engine or take some time. There is a lag for moving. So the person in the front will start moving, and it cascades, and it is like a low-pass filter. Okay? It's a low-pass filter, and by the time midway or the end, people realize already the signal has changed. But the model is that the entire segment moves synchronously. The moment it turns to green, entire segment moves synchronously and leaves you on the other side, which means that you are not in control. Okay? You go to the traffic junction, something else is in control, and the moment it turns green, synchronously all the traffic starts moving. Okay? You also have the traffic zones, school zones, or all those things. So for kilometers length. So that is where the traffic currents come. The moment you enter the zone, whatever is the vehicle, you lose control. Means you can relax. You can relax like that, no problem. So you are all going at a given speed as decided by the remote controller, and then it goes in the current, and you are left on the other side. So that is the traffic current. So this is also becoming popular. This is something futuristic, something that will happen. But technology is there to do it. We can do it, but it is not done. It is still futuristic, but lot of safety issues will come into the picture. Okay. So these are unresolved challenges here: fleet management, 2-kilometer range, as I said, traffic current junctions, autonomous management at school, hospitals, silent zones. These are all things that will come along due to this autonomous driving control steering. Okay. Now, second part, non-wheeled. Okay. As I said, locomotion, why should it be wheeled? Okay. Nature does not subscribe to wheeled motion. There are no animals, no creature which has wheels on its legs, right? Always it is some different types of protrusions, as you say. So nature locomotion is based on minimum energy principle. So where you have where you are talking in terms of, it's an inverted pendulum, and you push the pendulum, it has potential energy, it acquires kinetic energy and falls, and then you break the fall. You break the fall and the reaction pushes it up again, and so on. So it keeps going. Okay, so there is already energy in me. I try to fall and then break the fall and then keep on cascading. So only the loss amount, when I put my leg here, there is going to be a loss there, and then to that loss amount you have to eat. So as you eat, you will probably recover that particular thing. So that is basically how things. And the beauty of it is minimum energy. You don't need roads. The amount of energy that you put into making the road infrastructure is phenomenal, much more than. So you are talking of pollution, you are talking of saving the planet. Stop constructing roads, you will save the planet. Okay, it is much more than the cars that are driving on it. Okay, so you have to make all this 10 expressway, 10-lane highways, all those things, and traveling at fantastic speed. So multi-terrain, no roads, that would be at least closer to nature. Okay, that is closer to what we think should. This one. So some implementational. One PhD student worked just on that, Lilith, and rimless. This is a rimless wheel, and this can go on multiple terrains. Okay. So this wheel was basically to carry the oscilloscope. Actually, that should not be there. But there was an oscilloscope. You had to place it, so therefore a caster wheel was put there. Okay, and this was against my principle, but it is a magnet-based motor here. But anyway, that was one which was available easily to do, because the focus was not on machine design, focus was on this one, so we used that one, right? This is another rimless wheel. You can go up and down the stairs, where the design is on the mechanics of the wheel, and here you see that the inertia can change intra-cycle. So the drive, when you are doing the drive, is not same as doing it for a wheel where the inertia is, so J is constant, J is not constant. Okay. And there is this, this one, Theo-Jansen. So Theo-Jansen's linkages, okay, very simple. Okay. This guy must have been a saint. He doesn't give the derivation of how the linkages came. It is just an empirical. He says that these are the numbers. The sizes, the ratios of the linkages are this. Then you get smooth, organic, animal-like motion with one prime mover. That's all. So if you take a robot, you will have every wrist, everywhere, you will have prime movers coming in there, and this one. So Theo-Jansen's linkage is actually a fantastic innovation, but not exploited. It is something that that gives you really animal-like motion with one single prime mover, and at that and also another important thing is the distance from the ground. This is the ground. The distance from the ground is fixed. That is the beauty of this linkage. As it moves, I will just show you the movement. So there was not much analysis done on this, and then one of the students did a very detailed analysis on this one. Probably the only analysis you will find on this in bioinspiration. You will see that. But let me just show. Okay, what are the things that it can be used for? It can be used for you can go back to this mode. You can, okay, how? Okay, this is how you can go. So you can replace the limbs by an artificial this one, and then you have this prime mover here, and you will see that this distance will be kept fixed, and you can sit on it, and then you can drive artificial horses. Okay. You can also leverage it for senior citizens and people who are disabled, and they can wear that belt here, and then you have this, and then it can share the load. Okay. And let me show, see, this will not be clear unless you see this. So I have made this GIF image. So this is the kind of the same linkages duplicated 4 times and at different angles of the motor, and the motor will, and this profile of the leg movement is very close to the human profile movement of when you walk. Okay, when you walk, the trajectory very close to the human profile. And these are all plane linkages. There is only one prime mover at this point for all 4 the limbs. Okay. Just to give you a bit more clarity, I will, this is OpenSCAD. I normally use OpenSCAD, open source again. And for 3D printing, this is very nice. I do the 3D models on this. So this is again, okay, let me show the animation of this. I will animate it, it will give you a feel. Okay. Don't worry about these numbers. Okay. So you see this will be the motor location. Okay. This is the motor location here. Let me maybe include the other one also, other leg. Okay, you have these 2 legs here. Okay. So you see the animal-like movement. Nice animal-like movement. Okay. So this is with a prime mover. So the idea is to have this prime mover motor here, and then have that, and then attach it to the legs and share the load. It is still in research level. So therefore, I don't have results for that. Okay. So what I will do now, one more video, and then one more last slide, and then we will close. So this is just a video of some of the student implementations. So this is again, that was rimless wheel, another rimless wheel which can climb the stairs. It also has a camera in front, so you can monitor where it is going from remote. So this is monitoring through the camera eyes of the fellow, and then coming down also will be there. So you don't need special, what you call, infrastructure for that one. Okay. So this is the first rimless thing which was done, Lalit. And you would see the old, the auto rickshaw, the series hybrid. Yeah, this is the series hybrid, which was our first attempt at actually doing something. But it was in 2000. At 2000, I think the first vector control series hybrid on the road, I would say. But now, of course, you have, and this is the latest one. This is still with that bad motor, and we have removed that motor. We have rewound it. We have to now fix it. This is, you will see the screen, the windscreen also. I mean, this one. Okay, so this is that one. So I will not waste too much of your time. Coming back to, one second. Okay. Yeah, I will leave you with this. I will not, you just read it, and probably that could be the basis where you keep thinking, contemplating, and trying to move forward. Okay. Though I like the last comment, the best.
Hi, sir. My name is Naga Kiran. Thanks for the wonderful session. It was really informative. Uh, Studies I read your paper. I think you were part of the team which released the studies that HEV is better for India from IISc and a group of engineers. So really appreciate an alternate perspective. But what we do not seem to be considering is the amount of energy spent in extracting your fossil fuel and refining it and transporting it across the world, and then using it and burning and then creating.
Exactly. This is the point that comes up for your electric vehicles also, because electricity is coming from fossil fuel.
That is
So
true.
you are doing the same thing for both. And additionally, you are also transmitting it, and then additionally, you will have to make batteries, and then therefore, you are losing out.
So there was another study made elsewhere.
If you use renewable energy
Yes.
for charging, then it makes more sense.
So there is an option now.
Yes.
To use renewable
Yes,
energy.
yes, yes. Like
And the other studies showed that despite of long life cycle of both the vehicles, it's 1/5 the energy consumption. So I don't know whether that was considered into your studies. The energy consumption, I mean the emissions, overall emissions of EVs over the lifetime of ICE versus.
no, I have not considered the emissions. I go more like a Peltronist guy. I go more by the efficiency.
Agreed.
If so much amount of commission is being given to the thermal domain, that is bad.
True.
Okay. So emissions will get included there.
Yeah, I think that angle should be taken as well, because our lungs are equally important.
Yeah, that is why if you reduce the commission to the thermal domain, automatically that will come.
Yeah. Thank you.
Thanks for the wonderful session. Sir, how effectively is the problem of pollution control as well as the fast charging getting solved by green hydrogen?
See, what do you mean by green hydrogen?
Like
Where do you get it?
hydrogen produced by renewable sources, right?
Hydrogen produced by?
Using renewable sources.
Yeah, but how do you get the renewable sources in play?
Like there is a work going on.
See,
with
for
respect to
example,
solar power.
I will go right down to the basics. Okay, you have your second law. No, you have your first law. By first law, I cannot have a generation of energy, right? Your second law states that not only can you generate energy, there will be some amount of energy which will go to the thermal domain, right? So if I already had so much renewable energy, by passing it through a system, I have only lost some amount of energy, right? So even in the case of the PV, we're talking of PV, to make the PV cells, fantastic amount of energy is being used, okay? I already had that amount of energy, but I used it for making this, and I'm getting less amount of energy from that one. So that is fundamentally the basic thing, whether it be hydrogen, fuel cell, everything.
I see.
Anybody else?
But then, if you have to limit that, it will also mean that all of us has to become rishis and go and sit and meditate. That would be the least. But that won't happen. So I think we live with it. You just enjoy, forget about greenness.
Right. But isn't that, isn't the distribution going to play a role here, as in, like one-time generation like of PV cells, like energy used for
Yeah, they
producing the PV
deteriorate,
cells?
right? Now the problem is that now the PVs started, they started pushing for the PVs 12 years ago, and now they are reaching end of life for the PVs. Huge problem of what do you do with the PV? They have already been polluted with boron, phosphorus, all those doping, everything is done. You can't do anything with the silicon. It is just absolute junk. You can't reuse them. So what are you going to do with all that thing? It's going to be a serious problem henceforth. The first generation of PV has seen that. But now what are you going to do? So all this finally comes down to second law of thermodynamics, which will say that, okay, the best way is, if you really want to think about nature, walk. Don't do anything else. And even don't walk, just sit and meditate. That is the best, okay. But if you are not actually, you don't link it in a very hypocritical way. It will not. If you are doing action, you are going to lose energy. Okay. More action, more energy you will lose. Okay. The best way is like all our rishis, sit and meditate. That is the least amount of energy, least disturbance to the nature. But it's not possible. So don't even think about it.
Like EVs reduce pollution in the cities, but what happened to those batteries once they reach end of life?
Yes, that's what I
So
said.
Instead of cleaning, we are cleaning air, but we are polluting earth, which we consume and then we have different.
It is from a distributed, see, EVs, the problem is that one advantage I will say is that before in the ICE engines, every vehicle is a pollution source. Now it has been shifted from a distributed pollution sources to centrally located pollution source. But as far as the earth is concerned, planet is concerned, pollution is going to happen. Okay, heat is going to be generated, all those things going to happen. But at least now it is at a centralized way. You can kind of try to control it if you want to control it. There is that very important.
Sir, can solar cells drive the electric vehicles? How do you think of the future of
Directly.
solar cells?
You will need large amount. You'll have to lug around a large field of solar panels to.
So you don't seem.
Yeah,
it's
no,
not that-
directly it is not feasible. At least the if you are talking of with efficiency into consideration, so 200 watts per meter square. So typical cars, you are talking of 35 to 40 brake hours. If I take lower end cars, I think mobiles themselves are more than 50. But at least the lower end cars, if I take simplest ones like the Nano and things like that one, you will need a football field to drag along. That is not feasible. And that too only at noon you can drive. What about morning? You want to go to the office. What will you do at that time? What about night? So direct PV to drive this one doesn't make sense. You have to buffer it. You have to put it at some place, buffer it, and use it for charge.
Thank you, sir.
Because the energy densities are very low for PV. Nuclear, I am not so, I have not studied nuclear. But I can only go back and say that by the second law of thermodynamics, we should not do that. Because you will be spending more energy than getting energy out of it, period. Because, which means that I already had more energy to build a nuclear plant, to set up on all those things, and removal of the waste, all those energies are there. And I use that, and then out of the nuclear plant, I am getting some X amount of energy. And I know that input energy which I put is more than the output energy. I could have done without the nuclear plant. Okay, but I will not comment any further because I don't know what is going on inside the nuclear plant.